What do you? Good to see you guys. Happy Wednesday. And is this good for the warm up? You guys feel good about those? That was meant to be like hopefully just kind of furrowing more deeply the troughs in your head where this stuff lives. I don't know what that analogy is. Tracing over the same pathways that you've done before. This should be like pretty automatic, even without a calculator. I hope you can build a table. As you look at these, what nice things should, of course, you notice? Yeah, hopefully you don't do this without being like, constantly being like, these are inverses. You don't need to build two tables. You really don't even have to graph it twice. You just really are thinking, every time I get a point over here, 1, 3, for instance, over here you get 3, 1 for free, right? So that's a good thing to be thinking about. We want to, sometimes, I didn't maybe make it really clear, but sometimes we like to draw as a dashed line and label the asymptote. Over here, it has equation x equals 0. Under, the other thing is if we were to draw these on the same grid, you know that these would obey, since they're inverses, the inverse reflection principle. And when you do the inverse reflection, the asymptote, the x-axis maps to the y-axis, doesn't it? Under the reflection y equals x, doesn't it? The reflection over the line y equals x. So the asymptotes exchange places as well. And just keeping in mind all the things we've done earlier this year too. Once, not only should we be able to look at these graphs and graph them without a calculator really comfortably, you should also be able to answer questions like, what's the domain? What's the range? Where are the increasing, decreasing intervals? Are either of these bounded in any way? All those same questions we've been asking before. About continuity, about all that kind of stuff. Okay, so that's all kind of coming back to play. It's just we haven't mentioned yet, in the context of this unit, we haven't really mentioned much about graphing. So I thought, hey, let's put that on the stage today a little bit. As far as I'm concerned, when you're graphing, and you guys modeled this pretty well up here, when you're graphing exponential log functions, my rule of thumb is to get like maybe 2, possibly 3, or more points is fine. 2 is really probably enough though, plus the asymptote. And once you have that, like the asymptote gives you like the thing you're going to need to approach. And if you know the general shape, I think you're going to get a pretty decent picture with 2 points in the asymptote. Would be like kind of my rule of thumb. You want to do more, that's fine too. All right. So we're going to try and, as usual, we're going to try and enrich our discussion about graphing in ways that I think will be like fun for you, right? Just because I think that, like the warm-up today, you're good on those. Certainly, we should also be comfortable with any translation or dilations or reflections of those graphs as well. So we'll steadily get into a little more interesting as we go here, okay? The first one is definitely one that you would have been given in Algebra 2 class, maybe even the second one. So let's take a look at A together. And we'll just rehearse, just like we did in the warm-up, how you might have gone about doing this. There are kind of 2 ways you might approach it, right? One might be from the view of just like plugging in points. And actually, let's just do that for now. Let's just plug in some points and feel this out. I'd love to get at least 2 points and an asymptote. If you want to get 3 points, that'd be great too. But so someone give me a point on this. And someone give, do you know the asymptote? What do you know? Give me something.
0, 2.
0, 2. I'll take it. Wonderful. We're like almost done. Okay. What else you got? Anyone have an asymptote for me? Or another point would be great too. I'd love another point. Plug in 0. That's cool. What else do you want to plug in? Eric. At x equals 0?
No, y equals 0.
Good. Okay. Yep, y equals 0. Y equals 0 is the horizontal asymptote still. Okay, and once we talk about transformations, maybe that'll be clearer. Or you just remember, maybe you just remember that if there is a different horizontal asymptote, that's given by like a plus something or a minus something over onto the side, right? Or whatever. So yeah, we haven't talked about transformations yet, but he's right. And then you got another point for me, Peter? Or what do you want to say? -1, 6. Okay. Yeah, plugging in -1 is like a really slick choice, isn't it? Plugging in 1 might have been your first thought too, and what would you get there? 2/3. Plugging in -1 is actually kind of a prettier thing to plug in. But we'll put we'll, to the best of our ability, put 1 comma 2/3 on there as well. Anyway, now we have 3 points, and we have an asymptote, so I think we're good. Here we go. Something like that. All right. Beautiful, beautiful, beautiful. Did you have anything else to say about that? The other angle on this would be to think about transformations. So if someone were to ask you, what did we do to this graph, which we might call, like, I don't know, the parent graph or something, right? What do we do to that graph to get the one we're looking at? Someone want to give me the, here, no, wait, no. I'm going to pick someone randomly, and that person is Rachel. Tell me the 2 things, there are actually 2 transformations that you might talk about that you would have done to this graph in the bubble to get the one we're looking at here. Can you name them?
Flip over the y-axis.
Got it.
And then it's a vertical stretch of 2.
Great. Yeah, you guys agree? So reflection over the y-axis and then a vertical stretch by a factor of 2. Wonderful. What if I were to tell you that I think this is actually a horizontal translation? Would you believe me?
Yeah.
Because I'm the math teacher, maybe.
Yeah.
Maybe you would. I claim that that I can write this function as 3 to some power, negative t, right, is what we were given. Something plus c instead. Like, so I'm just using c as some constant. You think we can figure that out, what that constant would be? I claim that this is actually, could also be thought of, instead of as a vertical stretch or a shrink, as maybe a horizontal translation. I don't know. Some weird amount, maybe. Let me challenge you with this, because that's kind of a tricky question. I would love to be able to write this problem as, I'd like to be able to write 2 as a power of 3. Can someone answer me this question? 2 is equal to 3 to what power? It's easy to ask. Hard to answer, maybe. What is that? Not a nice number. What is it? I love how immediately you said that. It's beautiful, right? Like, I don't know, but it's log base 3 of 2, right? Does that make sense? Isn't that the power that turns 3 into 2? Isn't 3 to the log base 3 of 2 just 2? Okay? I mean, it should almost be a knee-jerk reaction, because like, that's what logs are. They're exponents. It's the exponent that's required to turn 3 into 2. Perfect. So can I convince you now fully that this is 3 to the negative t plus log base 3 of 2? So you could actually think about this, instead of a vertical stretch by a factor of 2, as a horizontal translation. Log base 3 of 2 units. To the left or right, whichever that you do first. Depends on which you do first. Okay? Anyway, just, that's for free. Like, I didn't charge you at all for that. Like, that's just free information right there. Like, did you need to know that? No. It was just fun. Wasn't that interesting? Okay, let's keep going. P of x. You want to talk about that one? Some of you have already maybe tried to start thinking about it, graphing it. Maybe I like that transformation angle, right? I know log base 6. Okay, because that was kind of fun to like think about translation, to think about transformations. I know what log base 6 of x looks like. I love that graph. How is this one similar? What have we done to it to get the one we're about to draw? Horizontally something? Stretch by something? Horizontally what? Something? Yeah, something. Say something, Peter.
Isn't 36x 6 times 6x, and then log 6.
Yeah, maybe there's. Yeah, maybe we just plug in some points. I don't know what's going on here. Yeah, when in doubt, plug in some points. What kind of? This is a horizontal stretch. It's actually a horizontal shrink by a factor of what? Yeah, 1 over 36, or 36 if you're dividing, whatever. One way or another. This is like a drastic horizontal compression, isn't it? So that's a good way to think about it. You got another? Wait a second. Is there another way to think about this? So you're suggesting a rewrite on this. So log base 6 of 36 plus log base 6 of x is what you're suggesting? Is just 2. Okay, so do you agree with Judah that this slick move is like pretty cool? This is really just I mean, we can think about it as a horizontal shrink by a factor of 1 over 36. Yuck. Or maybe we could think about it as a vertical translation by 2. Ah, I like that. I'm actually a bigger fan of that. Okay, that's cool. One way or another, it doesn't actually matter whether you thought about that or not. In the end, we can plug in points, can't we? What is the, before we even talk about any of that, you should have been able to maybe name the asymptote. What's the equation of the asymptote? And the domain is still 0 to infinity, right, even though we've done some stuff. There it is, x equals 0. And then, yeah, let's plug in some convenient values. You can use the equation we started with or the one we just now, recapitulated. 1 comma, you got something? 1 comma 2, loving it. What else we got? 6, 3. And would you admit, I mean, really, admittedly, both equations are equally easy to plug these values into, right? Like if I plug 1 in for x here, it's pretty easy to see that you get 2 for y. And if you plug 6 in, you get 36 times 6. Well, that'll be 6 cubed, so y is 3. Either equation is equally easy to plug x values into, I think. I don't know. You could also put in any other interesting x values you want. What else do you like? How about 1/6? That'd be a fun one. What would that be? 1/6 comma 1. 6 comma 1. I don't know, somewhere in there. Alright, so one way or another, we've got a couple points. We've got the vertical asymptote, and there's our pretty picture. I do caution you when you're drawing these, if you're thinking about if you have a calculator off to the side, remember your calculator doesn't do a great job of drawing. It's like try and actually graph log base 6 of 36x on your calculator. It does it terrible. Yeah, it has it truncates part of the graph off the bottom, usually it leaves off some of this stuff. And that's just because calculators are dumb machines, right? Calculators can only calculate. They cannot do mathematics, like that quote says. All it's doing is trying to make a really, really finely grained table, and it's just not very good at it. Like you have to, in order to see this asymptotic behavior on the log graph, you need to be plugging in values of x really, really often, close to 0, to get this full picture and this full behavior. And it doesn't do that. It's using a resolution that's maybe not quite fine enough to pick up the whole asymptote. So, all right. Well, that's warmed you up for this one. Let's try C. Again, we got no calculator. We're trying to do this without a calculator. I told you I just wanted to have some fun with you today. The book doesn't give you hard enough problems, I feel like. You're welcome. You're welcome. You're welcome. That's why I'm here. Yeah. Isn't that wonderful? Because at first you look at C and you're like, ooh. But then after a second, you just oh, I love this. Do you have that feeling? Who says what? Even look at it. Sometimes all you gotta do is yes. Do I hear some ahs once you see it? Don't look at D yet. Just look at C. Those who are having fun with this already and having an aha moment, is because maybe they're thinking like we did in the last one of a helpful rewrite. Right? Can you think of a helpful rewrite on the original function f of t? Once you do, the game is up. The actual graphing is not the fun part. Thinking about a helpful rewrite is the fun part. Maybe. Like Judah style, right? On the last one.
Because yeah, I got.
I don't know if you can bring those right there.
That's fine. Actually, you know what? I don't know if compulsive scroll with color, right? Like, I really like it because I was like, don't give anything away. You do the trailers like I'm like,
Like if
I
I'm
need to see that.
really
I need to see it.
Yeah, you can do that.
Do you agree with something down the argument experiments?
So it's -3 log of 2.
Yeah, there's a lot of movies I see.
Yeah, and then I
Good. Chess didn't really see that movie.
more because I don't even know if I'm allowed to do
I
that.
can't do that.
You ever have to take this yourself? I think they're all like sold out. So yeah, for sure. How are you doing on this? Come up with a good rewrite? Yeah.
I'm gonna legal.
You're thinking about your rules of blogs and all that. So who's got a better version of M of T for me? All right, are you ready? Maddie's gonna give it away. All right, this is the spoiler. Sorry, spoiler alert. If you didn't already think it through for yourself, I apologize. Maddie, go.
-3 times log 2 of parentheses t minus 4.
All right, so hopefully you can reason to that conclusion that this is also written this way. That's helpful because now I see it. I know what log base 2 looks like, the log base 2 of x graph, and this is just a couple little transformations back, right? In particular, the vertical asymptote is, instead of at x equals 0, is at, or yeah, t equals 4, I guess. Okay, and yeah, so we can think about this as a translation of the right by 4 and a stretch, a vertical stretch, and a reflection. Or we can just plug in some points, whatever you like. Give me a point on the graph. How about 5, comma 0? What else do we like? 6, comma -3 I like, yeah. Any other ones you want? 8, comma what?
-6.
8, comma -6 I like too. That's a good one. And how about 4.5? 4.5 comma 4.5 comma what? 3, yeah. 4.5 comma 3 is on the graph. Oh, we only got 4 points. That's way more than we needed. Sorry. Okay. So something like that, yeah. Those who are bored by this, you've already tried D probably, right? Okay, so here, I mean, let's all stare at D a little bit. Make D feel awkward. Stare at it. Are you good on C though? I mean, do you like the rewrite approach? I think it's helpful. It would be hard to do that problem maybe without a calculator, without having rewritten it that way. Okay, so this next one is a little crazy. Now we're thinking back to exponential functions. We also got an absolute value thrown in there. This kind of reminds me of something I've done before at one point in our lives. When we did like the absolute value compositions in unit 1, right? So we came up with like some rules or something. Right? So maybe along the way you're thinking about the graph of 2 to the t minus 3, or you're thinking about the graph of 2 to the t. You know what the graph of 2 to the t looks like, and you know what the graph of 2 to the t minus 3 looks like, so you might be thinking, well, those maybe are related to this, right? And you'd be right, absolutely. So, do you remember what that does if you replace t by absolute value t? Peter, you want to say? We have 2 asymptotes? Oh, that's an interesting proposition. I don't know. Yeah.
Wait. That mean rewriting as like 2 to the absolute value of 3
times 1/8.
You could do that, absolutely. Absolutely, you can rewrite it that way. You can think of it instead of a translation to the right, you can think of it as a vertical shrink by a factor of 8. All right, wait, hold up. So does anyone have an answer for me? What is replacing? I know what 2 to the t minus 3 looks like. What happens when we replace t by absolute value of t? Do you remember that? Yeah, Tim.
So what happens is the lower part, the part that would be on the left of the y-axis,
Okay.
ends up on the right again, going the other way.
The part on the left side of the y-axis gets copied over to the right side?
Yeah, in a way. So if you like,
What is it?
can be.
It's the other way around, maybe, actually. Okay. But let's forget the rules. Let's actually plot some points. Let's just see what happens.
Okay.
All right. When in doubt, move upon, or whatever they say. Okay. What values would you like? How about 2 or something, or 3? How about 3? Let's plug in 3. That's I like 3. If you plug 3 in, you get 1. Okay, I love it. But also, what happens if you plug in -3? You get 1. Isn't that obvious from the form of the equation that if you plug in 3, you get the same thing as if you plug in -3? So I think the thing that who was saying it? Teo or Judah or someone over here, and Eric were saying about this like whole copying one side over all that. That's just gonna happen right now. That's like happening already, like without us even trying or remembering a rule per se. All right, so that's good. You got another point for me? I mean, the rest is history now, right? 0, 1/8 is a good one, right? If you plug 0 in, you get 1/8. What if you plug -0 in? It's like a funny joke. Come on now. Right, okay. It's hilarious. Okay. Some people were like, wait a second, I've never thought about that before. Okay. All right, what about, what, you want another one? How about 5, what? 5, 4? I'll just trust you that whatever you said is right. 5, comma, 4, is that right? Oh yeah, okay. And -5, comma 4. All right, I've had enough. Let's do it. Here we go. And actually, I should say there's, maybe I'm drawing it. Stop. Hold up for a second. Pause. Hold up. We should just say there is actually, I've drawn it in such a way that it looks smooth. But I think if we were actually to look at this, and feel free to graph it on your calculator, I think we'd actually see there'd be like kind of like a shift hole shape. There'd actually be a little bit of a sharp point at the end there, right here, like a shift hole, kind of like the hole of it. That was my analogy. I don't know. This is what it looked like to me. You have like maybe a little bit of a sharp corner there. I mean, look at it. You tell me. I'm right. Are we done with that? All right. I mean, so we can throw some interesting things at you. I just want to like do that for the fun of it, but just for the love of the game. You know what I mean? Like just for fun. All right. Next slide. Okay. How about this guy? I feel like this is. I was trying to like be as cool as I could be coming up with these problems, but this is kind of convoluted. But it's the kind of thing that like you might. I was trying to think of what I might see on an IB test or something. They like to ask weird questions like this sometimes. Okay, so here's some crazy function. Here it is, log base 5 of a times x squared minus log base 5 of x, where a and x are positive. So I'd like to solve this equation. Set equal to 0 is what this says. Set that equal to 0 and solve for x. So let's do it.
A equals 1 over X. No. Really simple. Like the entire thing just dies. If you do something harder than say it doesn't fire to the right, we do it in about 4 lines. 5. No, it's 1 over X.
How are we doing? How are you doing? Are you having fun yet? What's going on out there? You like the condense like rain on the dew on the grass? Is that what you're thinking? Like
log 5 ax squared over x.
So what is that? Ax? Is that all we can do? Okay. And we're solving for x, so how do we do on that? We get ax equals Does that work? Ax must be 1.
Yes.
All right, so what's x? Oh, that's kind of fun. Okay, great. All right, and then did you already do the next part? This function is apparently the same as this function? What? Wait, really? Log base 5 of ax, that's the same thing as log base 5 of x minus 2? How can that be?
Would it just be x minus 2?
Say it again.
X minus 2 equals 3x.
All right, now this is, excuse me, this is, I should have written it more clearly. This is meant to be this.
Wait, what's the dot?
That is the pen.
Sorry. All right. Sorry, yeah, sorry if that wasn't clear. Yeah, Ruth. All right, well now that's assuming, isn't it, that the whole thing is equal to 0, isn't it? Wait, maybe I like that. I mean, if you plug in 1 over a, these should be the same thing. You should get 0 on both sides. That's not a bad way to do it. I think I like that. You should do that and tell us how you do. Did you do it? Did it work? Okay, okay. So maybe we're good. My first thought was to do this, but I actually kind of like what you said. One way or another, you need to see that log base 5 of a is equal to -2, right? Somehow or another. And actually, I kind of like Sabrina's idea of plugging in 1 over a just to make this thing go away. That's kind of cool. I like that technique. Yeah.
Did you turn 2 into a log?
Absolutely. Absolutely.
And then try to like match
Yeah.
up?
Sure.
So like turn 2 into log base 5.
And how about
25.
yeah? It'd be so it'd be minus log base 5, or you could do plus log base 5 of.
Either way.
Of 1 over 25, right? Yeah. Yeah, that's great. All right, so we figured out what a is. Awesome. Find f inverse. How do you find the inverse of f? Go. Have you done it yet? And then graph f inverse. What is f inverse? How do we do that? I mean, really, we should just be able to write it down, shouldn't we? F inverse of x is equal to, let's see here. The last thing that happened was minus 2. The first thing that happened was log base 5 of that thing. So if we go inverse, if we go in reverse order of operations, then we want to do plus 2, x plus 2, and then we want to do 2 to that power. Do you agree? Does that work for us? 2 to the x plus 2? Excuse me, 5 to the x plus 2. Does that work? And then graphing that, that's not super interesting, but here we go. What's a convenient value? How about negative 2? Isn't negative 2 a convenient value? Plug in negative 2. Negative 2 comma something. Negative 2 comma 1, yeah. And how about negative 1 comma 5, right? Are you with me? Or are you just okay, I don't know. I'm just plotting f inverse here. And negative 3 comma 1/5. Okay. How's that? There's f inverse.
Oh,
It says graph inverse, f inverse stunning. That's fun, right?
Oh god.
Did I do it wrong? Let's see. If I plug negative 2 in, I started with negative 2. If you plug negative 2 in, you get 5 to the 0. Okay. That was fun. All right. Hopefully you had a little bit more exposure to like graphing logs and making sure that you're comfortable doing that again.